In previous class, we have discussed the number system and their concept with some examples. Also, we have discussed what is HCF, what is LCM, what is prime factorization, and so on. In this lesson, we will discuss various questions can be asked from the competitive examination, especially from the number system. Those who are listening for the first time, please subscribe the channel. Question number 1. Find the LCM and HCF of 26 and 91 and verify that LCM into HCF equal to product of two numbers. To solve this problem, the first step we need to take is we have to factorize these two numbers into prime factors. Let's say, for example, 26 can be written as 2 into 13. 91 can be written as 13 into 7. All these four numbers are prime numbers, so I can call it as a prime factorization. To calculate the LCM, first of all, we need to multiply all the factors. In this case, 13, 2, 7. All these three numbers are prime factors of these two numbers. So, I can multiply 2 into 13 into 7 to calculate the LCM. So, my LCM will become 2 into 13 into 7, which is 182 is the LCM. But for the HCF, we need to consider common factors. Here, 26 has 13 as a factor. 91 also has the 13 as a factor. So, in the calculation of HCF, I need to take only the common factors here. So, here 13 only the common factor. I can conclude HCF equal to 13. So, I can say LCM of these two numbers equal to 182 and HCF of these two numbers are 13. So, now I find out the LCM, also I find out the HCF. Now, I need to verify HCF into LCM equal to product of these two numbers. So, the numbers which is given in the question is 26 and 91. We know that LCM equal to 182, HCF equal to 13. By multiplying, we will get 2366 as the answer, as well as by multiplying the number which is asked in the question 26 into 91, also we will get the 2366 as the answer, which means we have proven that LCM into HCF equal to product of two numbers. So, the problem 1 is completed. Coming to the problem number 2, find the LCM and HCF of following integers by applying the prime factorization method. So, the numbers which is given in the question 12, 15 and 21. First of all, we need to factorize these three numbers into prime factors. So, 12 can be written as 2 into 2 into 3, that is 2 square into 3. 15 can be written as 5 into 3. 21 can be written as 3 into 7. We have to observe all these factors are the prime numbers. Whether it is 2, 3, 5 or 7, all these numbers are prime numbers. So, I can call it as a prime factorization. As per the formula given in the question number 1, simply LCM equal to product of all the factors. Here 2, 3, 5, 7 are the factors of 12, 15 and 21 numbers. So, simply it will become 2 square into 3 into 5 into 7. By calculating, 420 will become the LCM of 12, 15 and 21. Then coming to the HCF. How to find the HCF? Simply HCF is the product of the common factor. Let's say here we have 3 as a factor here. We have 3 as a factor here also. We have 3 as a factor here also, which means 3 is the common factor for the 12, 15 and 21. So, I can choose as a 3 only. So, my HCF will become 3 power 1, which is nothing but HCF. Question number 3. Check whether 6 power n can be end with the digit 0 for any natural number. You have to remember always, if any number can be expressed as 2 into 5 form, then only it will end with 0. Here in this question, he gave 6 power n. In any manner, we cannot express 6 power n as a 2 into 5 form. So, I can say it doesn't end with 0. So, question number 6 is the over. You have to remember a note here. For any questions regarding a meeting, ringing at the same type of questions, we need to use always the LCM concept. Let's say, for example, sometimes we'll get a question, at what time the bells will ring together, at what time 3 or more friends meet together. So, in this kind of questions, we need to always use LCM concept. then only we will get the answers. Come to the question number. Which of the following is not a co-prime? To answer this question, first of all, we need to know what is co-prime. Simply, the co-prime is if any two numbers have HCF as 1, then I can say they are co-prime numbers. Let's say, for example, 2 and 3, their HCF is 1. So, this is co-prime. 4, 5, it has also HCF as 1. So, this is also co-prime. 6, 7, it has also HCF as 1. So, this is also co-prime. But in the case of 4 and 6, the HCF will become 2. So, I cannot say this is the co-prime. So, D will not be the co-prime. In this question, he is asking which of the following is not the co-prime. So, option D is the not the co-prime. So, I can choose option D. Come to the question number 5. Which of the following is irrational number? We have to identify irrational number in the given options. Let's say option A. What is option A given? Square root of 4. I can write 4 as 2 square. By simplifying, I will clear root and square. So it will become 2. So it's not 2 is not at all a irrational number. So option A is the not the answer. Come to the option C. 3 by 2, which is nothing but 1.5. 1.5 not at all a rational number. So option C also not the answer. 4 by 3 also a definite number, which means decimal number. It can be 1 point something. So this is also not the irrational number. Then come to the square root of 5. I can say square root of 5 as a irrational number. Why? Because any number which can be expressed as square root of p, where p is the prime number, that kind of expression must be the irrational number. See here, let's compare square root of 5 with square root of p. In the place of p, we have 5. We know that 5 is the prime number. So any number which is square root of prime number, that number must be the irrational number. So I can say square root of 5 is the irrational number. Come to the question number 6. If the LCM of 12 and 42 is 10m plus 4, then find the value of m. To answer this question, again we need to make the prime factorization for the both 12 and 42. Then we need to find out the LCM. When we make prime factorization, 12 became 2 into 2 into 3, that is 2 square into 3. 42 will become 2 into 3 into 7. To find out the LCM, we need to consider all the factors. 2, 3, 7. 2, 3, 7 are the factors. So I choose all 2 into 3 into 7. But make a note here. In the factors, to find out the LCM, always we need to take highest powered factor. In these common factors, 2 square is the highest powered. So I choose 2 square instead of the 2. So LCM will become 2 square into 3 into 7, that is 84. But as per the given problem, the LCM equal to 10m plus 4. So I can equate 10m plus 4 to the 84s. By solving, I'll get m as the 8. So my answer will be the option D. We have another method to solve the LCM, that is 2 6 the 12, 2 21 the 42. Again 3 2 the 6, 3 7 the 21. By multiplying 2 into 3 into 2 into 7, we need to multiply all these numbers with all this number in the sense 2. We need to multiply all this number 2 into 3 into 2 into 7. By multiplying all this number, we will get LCM. So this is the another method of solving the LCM. Coming to the question number 7. Which of the following is rational number? We need to find the which of the following given option is the rational number. Before solving this question, we need to keep in mind the concept. Which is rational number, which is not irrational number. Any number added or subtracted by the irrational number, it will become automatically irrational number. Okay, let's say here, this is the irrational number which is added by 2. So I can say this is also will become irrational number. This is irrational number which is added by square root 2. Then this is also will become irrational number. But in the case of option C, I can write square root of 4 as square root of 2 square minus square root of 5 as square root of 25 as I can write square root of 25 as square root of 5 square. By solving, we will get 2 minus 5, which is nothing but minus 3. Irrational number. Root 5 is the irrational number. By subtracting with another number, automatically it will become irrational number. So, A, B, D are irrational numbers. We need to find the rational number. So, the remaining only I have the option is option C is the rational number. So, my answer is option C. Note a point here. Any number added or subtracted by the irrational number will become automatically the irrational number. See the question number 5. 8232 equal to 2 cubed into 3 into 7 power n. Then find the value of n. We know that 2 cubed is nothing but 8 into 3 into 7 power n. By simplifying, we will get 8232 by 24. Why? Because 8 into 3 is the 24. By simplifying, we will get 343. So, I can equate 343 equal to 7 power n. 7 power 3 equal to 7 power n. I can compare with the formula, that is a power m equal to a power n. Then automatically m will become n, which means when two bases are equal, then the powers automatically will become equal. So, as per this formula, n will become 3. So, the value of n is 3. So, option C is the right answer. See the question number 9. The HCF of 2 cubed into 3 square into 5 and 2 square into 3 cube into 5 square. We know that to find out the HCF, we need to write the factors which have the least power. See here, we have 2 here, we have 2 here. Both are common for both numbers. So, I can write 2. But which power I need to take? In the calculation of HCF, always we need to take least powered number. So, 2 square is the least power. So, I can choose 2 square into, here we have 3, here also we have 3. But we have 3 square here, but we have 3 cube here. Which are the following we need to take? Always in the calculation of HCF, always we need to take least powered number. So, I can take 3 square. Then come to, here we have 5, here also we have 5. Which one you need to take? We need to take which has the least power. So, I can take 5. So, my HCF will become 2 square into 3 square into 5. That is option B. Question number 10. The HCF of 120, 150 and 210 is k square minus 6. Then find the value of k. Here also, we need to make prime factorization of these three numbers. That is 120, 150 and 210. 120 can be written as 2 into 2, 2 into 3 into 5. That is 2 cubed into 3 into 5. 150 can be written as 2 into 5 into 3 into 5. It can be written as 2 into 3 into 5 square. 210 can be written as 2 into 5 into 7 into 3. What is HCF? To calculate the HCF, we need to take the common factors. See here, 2 also here, 2 also here, 2 also here. So, I can take 2. But which 2 we need to take? The 2 as a factor which has the least power. That number only we need to take for the calculation of HCF. So, I am taking 2. Again, 3 also common factor. We have 3 here, we have 3 here, we have 3 also here. So, 3 also a common factor. So, which has least power? 3 power 1. So, I choose 3 power 1. 3. Again, 5 also common factor. We have 5 here, we have 5 square here, we have 5 here. Which is the least power? 5 power 1 is the least power. So, I choose 5. So, my HCF will become 2 into 3 into 5, that is 30. As per the calculation, my HCF is 30. But as per the problem, HCF is k square minus 6. I can equate k square minus 6 equal to 30. By solving, we will get value of k is 6. See the question number 11. The LCM of 2 cubed into 3 into 5 and 2 square into 5 into 7. We know that to find out the LCM, directly we need to take all the factors. So 2, 3, 5, 7 are the all the factors. So 2, 3, 5, 7 are the all the factors. But I am taking only 2 cube, not the 2 square. I am not taking the 2 square, but I am taking the 2 cube. Why? Because in the calculation of LCM, always we need to take, or always we need to consider the highest powered number. So I can choose 2 cube. So LCM will become 2 cube into 3 into 5 into 7, which is nothing but 840. So my answer is option D. Question number 12. If xy are prime numbers, then HCF of x cubed into y square and x square into y cubed. Previous problems, multiple times I said that in the calculation of HCF, we need to consider a common factor which has the least power. See here, we have x and y here. Here also we have x and y. But we need to consider which has the least power. So for the x we have least power here. So I can consider x square here into, we have y square here, we have y cube here. Which one we need to take? So y is the common, but we have y square is the least power. So I can choose y square. So it will become x square into y square, which is nothing but HCF. Question number 13. Which of the following is true? In previous class, I have several times explained that for any two positive integers a and b, HCF of the two numbers into LCM of two numbers, it will become the product of two numbers. So product of two numbers equal to HCF of that numbers into LCM of that numbers. So this is only the right option. Question number 14. Sum or difference of rational and irrational numbers need not to be irrational. This statement is wrong. Why? Because in previous example, I said that any number added to the irrational number or any number subtracted from the irrational number, it will become automatically irrational number. So option A is the wrong answer. Option B is sum or difference of rational and irrational number always irrational. Sum or difference of rational and irrational number is always irrational. Yes, this statement is absolutely right. When we add a number to the irrational number or when we subtract a number from the irrational number, it will become always an irrational number. So the statement B is the right. So automatically option C and option D will become wrong options. Question number 15. A physical education teacher wishes to distribute 60 balls and 135 bats equally among the number of boys. The greatest number of receiving the gift in this way are, here the question is simple. A PD teacher has 60 balls and 135 bats. He need to distribute these balls and bats to the boys of the class without remaining as a waste. So he need to completely distribute 60 balls and 135 bats to the boys of the class, which means he doesn't have left any ball or bat. So what are the possible number of boys can take equally? This question is about equal sharing of items with maximum boys without leftover of items. Always remember that in any problem of distribution of goods, arranging the things in rows, packaging of items extra, for this kind of questions, always use the concept of HCF. Here, we need to use the concept of HCF. First of all, we need to find the HCF of 60 and 35. Simply, first of all, we need to make a prime factorization for the 60 and 135. 60 can be written as 2 into 2 into 3 into 5. That is 2 square into 3 into 5. 135 can be written as 3 cubed into 5. We know that HCF equal to the product of least powered common factor. 3 here, here also we have 3, which means this is the common factor. But we need to consider least powered for the calculation of HCF. So I choosing only 3 here. So I choose 3 into 5 also common factor. Here Here also we have 5, here also we have 5. So I can consider 5, which is the least power, that is 1. So I can say 5 power 1. So the HCF will become 3 into 5, which is nothing but 15. Okay. Now from the given data, we find the HCF of 60 balls and 135 bats are 15. Okay. We got the HCF as a 15, which means that maximum 15 boys can share the bats and balls equally. In the sense, all the boys get equal amount of bats as well as all the boys get equal amount of balls. Here we got 15 as a HCF. So the number of boys in the class are 15. We have 15 boys, 60 balls, 135 bats. When we distribute 60 balls in 15 boys, it will become 60 by 15, which is nothing but 4 balls. As well as when we distribute 135 bats among the 15 boys, each boy will get 9 bats, which means in the class of 15 boys, every boy will get 4 balls and every boy will get 9 bats. After distribution of 4 balls to the every boy and 9 balls to the every boy, the PD master doesn't have any leftover material, which means he had distributed entire material by using the concept of HCF. So each boy among the 15 will get 4 balls and 9 bats. So no remaining items left. See the question number 16. Which of the following numbers are prime numbers? Carefully examine each option. See, come to the option D. 43 is a prime number. Yes, we know. 47 also a prime number. 53 also a prime number. But 49 is not a prime number. Why? Because this is also divisible by 1, 49 as well as 7 also. What is the prime number? The prime number is any number which can be which is divisible by itself and 1 only. But in the case of 49, it is divisible by 1, 49 as well as 7 also. It has more than 2 factors. So I can say 49 is not the prime number. So option D will become wrong. Then come to the option C. 17 is a prime number, 23 is a prime number, 29 also a prime number. But 25 is not the prime number. Why? Because this is divisible by 5 also along with 1 and 25. So it has more than 2 factors. So option C also wrong. Come to the option B. 35, 39, 51. 57 is the prime number, 51 is the prime number. See here, 13 is not the prime number as well as 35 also not the prime number. Why? Because 7 5 is the 35, 13 3 is the 39, which means it has more than 2 factors. So I can say option B also not the right answer. So what I have remaining? Option A only. In the option A, 29, 31, 37, 47, 41. All these numbers are prime numbers. So I can choose option A as a right answer. Question number 17. Check whether the following numbers are prime numbers or not. Check whether a number is prime number or not. We need to follow 3 steps. First step is we need to identify a number which is more than a given number. Also, it has the perfect square. That's the first step. The second step is we need to check the divisibility of P by all the prime numbers which are less than n. The third step is if any one prime number is less than n divides the number P, then P will not be the prime number. So these are the 3 steps to be followed. Now I will explain step by step with the given examples. Here in the question number 1, P is the 53. So P is 53. What is the square number which is near to 53 as well as it is more than 53? So that is 8 square. 8 square is nothing but 64. So 64 is more than 53. So I can take 8 square. Why I am taking only the 8 square? Why can't be the 9 square? Why can't be the 10 square? The reason is we need to consider the square number near to the given number. So 64 is the square number very near to the 53. So I am choosing the 8 square. Step 1 is complete. The second step is we need to check divisibility of all the prime numbers less than this number. So we need to check the divisibility of all the prime numbers less than 8. We know that what are the prime numbers less than 8? 2, 3, 5, 7 are the prime numbers less than 8. We need to check each one. 2 is dividing the 53? No. 3 is dividing the 53? No. 5 is dividing the 53? No. 7 is dividing the 53? No. 2, 3, 5, 7 prime numbers which are less than 8, none of them dividing the 53. So I can say 53 is a prime number. If any number of these numbers divide the 53, then it will not become the prime number. In this case, all these 4 prime numbers not able to dividing the 53. So I can say 53 is the prime number. So in this manner, we need to solve, or we need to identify any number whether it is prime number or not. In the question number 2, the number he is given is 137, that is P equal to 137, N equal to 12. Why? Because why only the N is only 12? 12 square is 144. So the value of 12 square is 144. 144 is the only number near to the 137 as well as more than 137 as well as it's a perfect square. So N square is more than P, which is nothing but 12 square equal to more than 137. The second step is we need to identify prime numbers which are less than 12. We know that 2, 3, 5, 7, 11 are prime numbers which are less than 12. We need to check the divisibility of each prime number with respect to the 137. See here, 2 not dividing 137. 3 also not able to divide. 5 also not able to divide. 7 also not able to divide. 11 also not able to divide. Means all the numbers which are less than n not able to dividing this number. So it will automatically become the prime number. If any of the prime number dividing this number, then it won't be the prime number. So in this manner, we need to check whether given number is prime number or not. Here in our problem, no prime number less than n is dividing the P. So 53, 137, 41 are the prime numbers. Anyone have doubt in the questions I have explained? Please comment your doubts in the comment section. In the description of channel, community link, Instagram link, Telegram link also given. If you want to follow the channel. Here you will get all the classes as well as materials as well as mock test for the practice. If anyone want a paid mentorship, you can reach me through my number which is mentioned in description of the channel. Thanks for watching. Keep watching. Stay tuned with Sigma e-Learning, Smart Way to Excellence.